Welcome everyone. Here we are going to discuss about bandstop FIR filter. So FIR filter is a type of digital filter where output at a given time is a function of only the current and finite number of past inputs. Unlike IAR filter, FIR filter are non-recursive in nature, which means that they don't have feedback loop and they don't rely on past outputs to compute the current output. So this is a fundamental difference that indicates that it is a preferred choice for the applications where stability and phase responses are important. The key properties of the FIR filter is that it is having linear phase response. So this means that all frequency components of a signal are delayed by the same amount of time. So this uniform delay prevents phase distortion. So this is important for preserving the integrity of the signal's waveform. For example, in audio processing, a linear phase ensures that all frequencies arrive at the output at the correct time, maintaining the natural sound of the audio. So because of their non-recursive structure, FIR filters are inherently stable and there is no possibility of an output feeding back into the system and causing it to become unstable or making it oscillate. So unlike IAR filters, which require careful pole placement to ensure stability, but FIR it is not so. But the significant drawback in FIR is that they often require much higher order, that is a large number of filter coefficients to achieve the sharp frequency domain specification as like IAR filter. So this makes them more computationally intensive and it can introduce longer delay, which may be a concern in real-time applications. So the most common methods in designing FIR filters are window method and frequency sampling method. So window method, it is a straightforward approach. It begins with ideal frequency response like a perfect brick wall filter, and it uses an inverse Fourier transform to find its corresponding impulse response, which would be infinite in length. To make this more practical, the impulse response is truncated by multiplying it with window function like rectangular, Hamming, Hanning or Blackman window. So here we are using rectangular window. So this process effectively cuts the impulse response to a finite length. So the choice of window function is a trade-off between a narrow main lobe in frequency domain or which comes at the cost of higher side lobes. So which means that there is a sharp transition band in the narrow main lobe, and higher side lobes it is having more ripple in passband and stopband. And another method is frequency sampling method. So frequency sampling method, it provides a direct way to design a filter, that means exact specification at specified points. The desired frequency response is specified by a set of discrete sample points. The filter's coefficients are then found by performing the inverse discrete Fourier transform. So the applications of FIR filters are, it is used in audio signal processing, where it is used for equalization, noise reduction and crossover networks in speaker systems to ensure no phase distortion is introduced to the sound. And then it is used in digital communication, that in which it is employed for channel equalization and anti-aliasing to preserve the shape of data pulses and prevent inter-symbol interference. Now we are going to see how we are going to design the bandstop FIR filter. So here we are going to design linear phase FIR bandstop filter to reject frequencies in the range of 0.4 pi to 0.65 pi radian per sample using rectangular window by taking 7 samples of the video sequence. So if it is a bandstop filter, then HT of e to the power of j omega should have a 3 range of omega values, that is from minus pi less than or equal to omega less than or equal to minus omega c2 and minus omega c1 to omega c1 and then omega c2 to pi. So here we are finding out the inverse Fourier transform. So hd of n is equal to 1 by 2 pi integral minus pi to pi hd of e to the power of j omega j e to the power of j omega n into d omega. So here we will be having 3 integrals, and when the integral limits changes accordingly, like minus pi to minus omega c2 and minus omega c1 to omega c1 and omega c2 to pi. So here the exponential term value is e to the power of j omega n minus alpha into d omega in all the 3 cases. but only the limits changes. So when we integrate it and substituting the limit and then simplifying it, we can get sine omega c1 of n minus alpha plus sine pi into n minus alpha minus sine omega c to n minus alpha divided by pi into n minus alpha. So except for n is equal to alpha, so we have to find the value of ht of n for alpha. So the ht of n for alpha will be 1 minus omega c2 minus omega c1 divided by pi. So this is achieved with the help of L'Hospital's rule, where limit theta tends to 0, sine a theta divided by theta will be equal to a. And then since we have used a rectangular window here, the wn function becomes w r of n, which is equal to 1 for n is equal to 0 to n minus 1 and 0 otherwise. Hence for all the hd of n values, it is multiplied with this w r of n in order to obtain the h of n. Then the h of n is actually substituted in order to get the h of z. So here the alpha value is found out with the help of n minus 1 by 2. So the n value is 7 here. So here we have 7 minus 1 by 2, which is 3. So here alpha value is equal to 3 and n minus 1 is 6. Hence h of n will be equal to sine omega c1 n minus 3 minus sine omega c2 n minus 3 divided by pi into n minus 3 for n not equal to 3. And then when if n is equal to 3, the value is 1 minus omega c1 minus omega c1 divided by pi. Hence now we are substituting the values of n is equal to 0 to 6 in the instead of n in the h of n, and then we are obtaining the values as minus 0.0458, 0.2223 and 0.0191, and then for n is equal to 3 it is 0.75, and then for 4, 5, 6 it will be the mirror one of n is equal to 2, 1 and then 0. This is because of the symmetric condition. Hence the transfer function is h of z is equal to summation n is equal to 0 to n minus 1 h of n into z to the power of minus 1, where n minus 1 value is 6. Now we are substituting all the h of n values here, and then we are obtaining h of z as minus 0.0458 1 plus z to the power of minus 6 plus 0.2223 z to the power of minus 1 plus z to the power of minus 5 plus 0.0191 z to the power of minus 2 plus z to the power of 4 minus 4 plus 0.75 z to the power of minus 3. Thank you.